Now, welcome to the lecture of physical significance of characteristic impedance and surge impedance loading. So, let us discuss the physical significance of characteristic equation. We know the value of characteristic equation is equal to under root z by y, whereas z can be rewritten as r plus j omega l and y can be written as g plus j omega c. So let us consider for a lossless line, resistance will be 0 and g will be 0. So zc can be written as L by C, under root L by C, which is known as surge impedance loading. So surge impedance loading is basically characteristic impedance of a lossless line. So, surge impedance load or natural load of the line is considered to be Z0 equals to under root L by C. So, what it basically means? For a lossless line, reactive power absorbed by a line is I square omega L, where L is the series inductance per phase. Due to shunt capacitance, the VAR generated by the line will be V square omega C. So again I am repeating, reactive power absorbed by the line is obviously due to inductance, that is I square omega L, and the VAR, that is reactive power, is generated by the shunt capacitance, which is given as V square omega C. Now suppose VAR generated is equal to VAR absorbed, then in that case I square omega L will be equals to V square omega C. So from this equation, V upon I will be equals to under root L by C, which is known as surge impedance. So for the overhead line, this surge impedance will be 400 ohms per phase and angle will be between 0 to 15 degree. For underground cable, it will be 40 ohms. Point to be noted here that for underground cable, this surge impedance has a lower value due to the higher value of capacitance in case of underground cable, as we use more insulating layers in an underground cable. So in an underground cable, capacitance is dominating. So next is our bundled conductor. So bundled conductor generally has lower value of surge impedance. The reason behind this is inductance value will be lowered, as we discussed in the class, that by using bundle conductor the value of inductance can be reduced. So for bundle conductor we have a lower value of the surge impedance. So for the two subconductors the value will be 220 omega per phase. Now the important part is surge impedance loading. So let us first discuss the definition of a surge impedance loading. Surge impedance loading of a line is a power transmitted when the line is terminated through a resistance equal to surge impedance loading. Again I am repeating SIL, it is also known as SIL, that is surge impedance loading of a line. Let me write here, this is known as SIL of a line is a power transmitted when the line is terminated through a resistance equal to the surge impedance loading. So here PR will be equals to VI, because since line is terminated at surge impedance which is purely resistive, that is cos phi equals to 1. So PR will be equals to V into V upon Z0, whereas Z0 is a characteristic impedance. So V square upon Z0 per watts will be the power transmitted through that transmission line. If VRL in kilowatt and Z0 is in omega, the total surge impedance loading will be VRL square upon Z0, and it will be given in megawatt. So power transmitted through a transmission line can be increased either by increasing value of voltage or reducing the surge impedance loading. So there are various methods for, since VRL, we as we know that we always transmit power by at high voltage. So reason behind this is to increase the power transmitted by the transmission line. So one of the method is by increasing the voltage of a transmission line, and second is reducing the Z0. So let us discuss how we can reduce the Z0. So we have two methods. Capacitance, since Z0 can be reduced, as Z0 formula we have is under root L by C. So if we increase the capacitance of a transmission line, this will result into the reduction of surge impedance. So capacitors in series or parallel in a transmission line can be used to reduce the surge impedance loading. So we have two methods, series capacitors and shunt capacitors. So let us discuss the pros and cons of a series capacitor and the shunt capacitor. So in a series capacitor will be connected in series with the transmission line. So the overall impedance will reduce as it will decrease the line inductance, and also going to improve the stability also. But whenever there will be the short circuit, then there will be the difficulties in order to control the current. Now another is a shunt capacitor. So shunt capacitor will be connected in parallel, which will result into increase in phase shift. Now here we discuss P equals to Vs VR X sin del. So this sin del is a very important part. So your system will be stable when del should be up to 90 degree. Above 90 degree, system becomes unstable. So when we use shunt capacitors, it will result as it increases the phase shift, which will result into the decrease in the stability. So this lecture ends here. Thanks for watching.